about toxin, about toxins. The toxin, and about the chemicals that affect with toxic behavior affecting our environment. With all the environment per se, so not only humans are affected, but soil and tap water, aquifer, rivers, and oceans and animals. Everything is around us is affected by those toxic chemicals. Now, those toxic chemicals are produced by humans, or they're produced by bacteria, or fungi, or other processes. Not only humans are participating in this mishaps, but even some bacteria and some fungi are interacting with the environment and producing those toxin or those toxic chemicals. Now, there is two definitions here in this slide. As you said, make a note always for those definitions, because those are the publisher preference to ask those questions. One of this is the conservation medicine. What is really the definition of it? Well, conservation medicine is attempts to understand how our environment changes threaten our own health. Well, we are really using medicine to fight back those toxin or those toxic chemicals. And the ecological disease, humans are not only ones to suffer. Wildlife means what the diseases, they're really affecting the ecology of our universe or our planet. So is diseases, those are affecting the ecology balance in our planet. So that's what those two definitions. Overuse of antibiotics breeds superbugs. That's this subject is well known. Some bacteria and some fungi, they will develop sort of a mechanism to really resist the antibiotic we are using. And I will show you the picture here, how this the whole thing here. Some mosquitoes, the same thing, they are producing malaria. As I said, those are emergent diseases, but they are coming after dying out. They are coming back after 20 years plus years. They are coming back. So, but some of the mosquitoes are developing their own resistance to whatever chemicals you put on them, whatever antibiotics you put on them. And one of the other factors is affecting this overuse of antibiotics is the human himself or herself by using those antibiotics carelessly. So and you can see here, if you look, this is how microbes and lower bacteria is really are developing their resistance to antibiotics. So here's a healthy. This one here, let me just show you here. You enter the this is healthy cells or healthy bacteria, if you wish. Those are healthy bacteria here. And then you are exposing them to continuous dosage of antibiotics. They will develop resistance to it. And you can, out of this one here, the mutation happens in this area. See the green stuff here? You can see there is a green line, small tiny green circle here, a line, not red. All the healthy ones, they have red, like a red cell. And then you add the antibiotics. Some of the cells of the bacteria, they develop some sort of resistance to this incoming antibiotics, and therefore this antibiotics is not working on them. So that's the whole idea. Now, this one takes time. It's not happening. The resistance or to the antibiotics is not happening in 1 day, 2 days. It takes hundreds of days or sometimes hundreds of years to develop a new breed of bacterium that really has the ability to do that. So maybe you have a lot of breeds or generations of those type of bacteria dying, but in the process, after a long time, they develop this resistance for this type of chemicals. And this is the same thing for as long as the dosage is small amount, we can, as a human and other marine life, we can develop small, tiny resistance to those antibiotics as well. So if you have a disease and you use antibiotics to get rid of it, you'll see after a while, if you use these antibiotics almost in every day, so your body might develop somehow small amount of resistance to these antibiotics. You'll not see any effect out of it unless you go for higher dosage out of these antibiotics. Environmental toxic, the toxicology is study of the effect of the chemicals on our environment as such, and not about all the environment, but the effect on the planet itself, because those toxic chemicals, as I said, they are produced by humans and by fungi, by bacteria, and those we call them toxin, whatever toxic material is produced by humans or bacteria, whatever the source of the manufacturing of those bad chemicals is affecting the whole environment, the whole planet, the whole ecosystem, the whole planet as such. So chemicals such as here it tells you drugs, UV radiation, electromagnetic forces, all this is affecting the health, and mostly is nowadays is chemicals, because the chemicals are seeping through the soil into the rivers, into the oceans, into deep tap waters there, and then contaminating the source of drinking for humans and animals and marine life. So toxin, those are produced, chemicals are produced by fungi, bacteria, humans. They are very harmful in a large dosage, but if you dilute them, sometimes they are not that bad. But the problem is everyday exposure of those chemicals will build in your body some resistance to those toxin in a small amount, not in large amount. Large amount, most of those toxin or most of those toxic chemicals are hazardous and lethal, can cause death. And that's what it says. Irreversible damage means death. So it ends up killing the marine life. All living creatures will be affected. So environmental toxicology here is a combination of both. It's really studying the effect of toxic material or toxin on the environment itself. So two words together is related to each other. Toxic chemicals produced by humans, bacteria, fungi, all those stuff here, or radiation, as small as a microwave. Can you believe this microwave can cause damage? If you expose yourself microwave radiation every day, you are close to your microwave every day for a long time, that will affect your body as well. In a sense, your cell will start mutating. So you are generating tumors which turn out to be cancer at the end, correct? So the environmental toxicology here is two words together combined, the effect of toxin made by humans, fungi, bacteria, whatever radiation, whatever source of radiations are on the environment. That's what it really says. And then how do toxins affect us? Well, we talked about this now. As I said, the textbook publisher like to have everything by definition, but we know that the whole summary of this slide in the PowerPoint, those are all toxin and all toxic chemical, wherever the source of they are, they have a negative impact on our health and our environment as such. So they can't be positive. They're always negative impact. That's what all these slides is really all about. So we have negative. And then now the definition of those. What we mean, for example, antibody. Antibodies is protein produced by the bodies to fight those toxic chemicals or toxic materials entering the body, correct? Bind them and then restrict their movement. That's the antibodies. The antigens are such as pollen, bacteria. Those are formed by white blood cell and stimulate the production of specific antibodies. The allergens, substances that activate the immune system. So those are definitions that the textbook is using, but the whole conclusion of the whole slides is you have always those toxins have negative impact. They cannot have positive impact on our body and our environment, bodies and our environment as such. Sick building syndrome. This is formaldehyde. Formaldehyde is used in painting. And painting chemicals is used in the plastic. Is used in many things. And if the building has poor ventilation, and therefore the heat inside this building will be enough to kick out formaldehyde from whatever the products you have inside, wood products, insulations, painting. So you get inhaling this and you'll get sick. What is formaldehyde is used to? Somebody will tell me? Somebody is taking a biology class?
Formaldehyde?
Yes.
For embalming.
What's that?
To embalm a deceased person.
Correct. We call it formalin. Did you hear about formalin? No? Formalin? It's a liquid. When you go to biology lab and see AMP lab, you see a lot of some dead stuff here, frog, dead cat, whatever, is put in a solution, correct? This solution is what?
Formalin.
Formalin. And formalin is the mixture of formaldehyde and methanol. Formaldehyde. Methanol is a killer, can cause 15 mils of it blindness. You can't be blind if you swallow just a small amount of it. You'll be blind for life. And formaldehyde is the same thing. It's killing all the bacteria. See, the dead body is preserved. Why? Because you keep this dead body out of bacteria, because the bacteria will eat on this dead body inside the glass. Correct? So you put the solution, and this solution is driving this bacteria out. If the bacteria will enter, both of them, the methanol and the formaldehyde, they have very negative impact. They will kill any bacteria coming in, and you can preserve this corpse or dead body for hundreds of years. Nothing will happen to it as long as there is the solution is not evaporating. If you have a solution, you can preserve a body for hundreds of years with no problem. So formaldehyde. So and let me just show you right here the name of the when you add formaldehyde to alcohol, it is formaldehyde plus alcohol. You get this solution called formalin. Formalin is a solution used for preserving dead bodies. So for long time. So, okay. So alcohol can be used, ethanol or methanol, but methanol is more aggressive than ethanol. Somebody will tell me something related to this, to sick building syndrome. Somebody? Yes. What's that? Correct. Perfect. What's another example? Well, somebody will tell you, do not warm your food with this white plastic box you have. Why? This plastic box is made of chemicals. When you put this one to heat, some of them, the chloro and fluoro halogenated organic compound inside this plastic box will be released, correct? And where they will go? You'll end up in your food, and you eat the food with those compounds. Are you following me here? And those compounds are really initiator for a lot of tumor chemical reactions. Are you following me here? So do not take your food in a box and put the whole thing inside the microwave. That's a no-no. That's a no-no, because when you heat the box, all this chloro and fluoro halogenated compound will be driven out, will be evaporated, and then you open the door to eat. All those chemicals are ending up in your food. You eat a free radical initiators, which is really tumor initiators inside your body. So do not. If somebody will do this one for a couple of years, I can guarantee, I'm not a physician, but that person will develop different types of cancer, whether it's lung, whether it's liver, whether it's kidney. That's because those compounds, halogenated and, chlorinated and fluorinated compounds from the box you have, they will generate a lot of free radicals. So that's not healthy. So whenever you are warming your food, get yourself a ceramic plate. Ceramic plate. Do not use any, even paper tissues, depending what the type of tissues you have. Even tissues can cause, although tissues are wood, cellulose is harmless, but I don't know what's inside the tissue. So the best safest way to warm your food is get yourself ceramic plate and put your food in the ceramic plate. Ceramic is not decomposed by the heat of the microwave. You need over 1,000, 1,500 degrees to decompose the ceramic. The ceramic is very stable. So anyway, so just information that we have to be aware of. Okay, so classes of harmful agents. Well, you have carcinogenic. We talked about carcinogenic chemicals. Those are mostly halogenated, fluorinated organic compounds that can cause cancers. Okay. Teratogens, those chemicals can affect the infant births, okay, and mutagens. They can affect the synthesis of DNA, RNA, mRNA. All those they mutate the RNA and DNA. So those we call them mutagens. So just a definition again. This is 4 definitions here. You get the example of those neurotoxins. Those the same thing. Those are chemicals that can affect the neurons. And what do you mean with neurotoxins? You think about? Somebody will tell me. Yes. What's that? Yes, but the simple one, what the simple one is steroids, correct? Or steroids. Steroids can be found in opium, can be found in marijuana, can be found in all those drugs. Those drugs stimulate the brain cells, and prolonged usage of them can cause what? Destruction of the brain cells. So that's neurotoxin. Those are compound, are steroids, correct? Mutagens, again, those are destroying the RNA, DNA. They go into the cell, and they stick onto DNA and alter the DNA and the mRNA and RNA. So they really destroy those. And carcinogenic, I give you an example. Any halogenated compounds that can cause carcinogen, can cause cancer. The endocrine disturbers affect hormones. That's always the case. Chemicals are really affecting our hormone functions. Where those hormones are produced in the human body. I know some of you are taking biology classes. Biology? No classes? Okay, no class biology. Okay. So where those hormones are produced in our body, in insect body, in animal body? Where do you think those hormones? What's the very important organ that produces most of the chemicals we have in our body? You should know that. That's a general. No. General gives, that's a computer. That's organizing the signals, what they call the function of each organ is organized by the ISU. Oh, what's that?
Is it the pancreas?
No. Something near the pancreas. What's near pancreas? Liver. Liver is about 80 to 90% of all the chemicals produced in the body is produced in the liver. Liver is very important. If you use your liver, you lose all the chemical produced in your body, and you'll be subjected to many diseases, and you cannot survive. I mean, with all the implants, the most difficult and the most implant is beside the brain. We did not have the brain implant yet, but liver implant is the most difficult because it has to match the database. You have it in your brain. Brain is your computer, and it saves all the database about your fingerprinting of all your organs inside your brain. And if this liver is not, database of it is not matching the brain database, the liver implant will be rejected by your body. Even if the doctor, physician, they give you a lot of chemical to suppress this rejection, a couple of years you will die. I mean, or sometimes a couple of months, because the rejection of the brain so high is not allowing this liver to function, producing those chemicals, or those hormones. All the hormones, all those chemicals, 90% of them are produced inside the liver. Here is show you how those steroids, all those steroids, all the steroids, most of the steroids they have 4 fused cyclic rings together, fused together. If you have organic, some organic. So those are very bulky molecules, and they enter the cell, and you can see the DNA there. They enter the cell, and they are coming in. Now, the hormones, the female hormones, estrogen is produced inside the liver. The male hormone is testosterone, is produced inside what? Inside the cell. So the cell is using those hormones to control all the activities, our activities, human activities, as well as insect activities. Now the problem is if somebody is taking steroids, those steroids will interfere with all the mechanism of the cell itself. So you can see they come and stick to the DNA, sideways, as you see the DNA inside, and from there then you have the problem. So estrogen will come in. That's the area here is okay, but when you have this red, that's what the steroids coming in. See, the idea is hormones will come in, will be exchanged by RNA, by DNA, and then you produce mRNA. mRNA is a writing hormone of the DNA. So it's like a backup. It's a backup hormone. You have a DNA and all the genetic features of the person is inside, encrypted, and it has a backup mRNA there. So now, if somebody is taking steroids, then guess what? This will come and replace will disturb the real behavior. You don't have to memorize this, but you can see, and those are stimulants. A person who is really taking the steroid is a sick person, has to go to hospital on the rehab process to get out of this disease. It's a disease, so it's not just a normal case. It's very difficult to get those out of the bloodstream because they are there inside and they have to be flushed out, and the person has to stay in the hospital for a couple months to get this. This is like a sick person. Mobility of toxic substances, you can see here from the from the frog here, it will be affected. All those chemicals we are using will be dumped inside the rivers, indirect, inside Tabor. If it's not clean, they will go back to the soil. Frog is eating from the soil, and some insect will be affected. Some of it will be getting out in the skies, evaporate and coming back. So, and in some areas where those chemicals are very high dumped inside the rivers, you will see frogs are born with defective organs. Some of them, they have no legs, they can't jump. Some of them, they have no eyes. So it's a lot of disfiguring of the creatures on our environment, in our planet. All those chemicals, if dumped inside and it's not clean, this area here, it's very crucial when it's dumped here. We just when those chemicals dumped inside the Tabor or rivers or lakes, this area is very important. It has to be recycled, and all those toxic chemicals has to be pulled out of the Tabor and let the normal Tabor go through the cycle. Correct? That's what's they really move very fast, and their movement it depends on the solubility of those toxic materials. Some of them they are Tabor soluble, some of them they are not Tabor soluble. They stay there and they will go to the soil. They are soluble just in oil or fat. So that's the whole thing here. And the poor frog here will be affected by whatever it's eating here from the grass or insects will mutate itself, and you'll end up. Did you see a frog without legs? Not here, but you see a frog without legs, disfigured. Go and Google this and see the mutation of our animals. I mean, of the animals inside. In the areas there is no policies, no chemical recycling, no nothing. Some people just dump their chemicals inside the rivers and ponds, and whatever happening then it will affect the animals over there. Some compounds dissolve in, as I said, that's we say that's we had in chemistry. We tell our students polar solution or polar chemicals are soluble in polar solvents such as Tabor. Tabor is polar, means conduct electricity, correct? Anything conduct electricity is polar, and dissolving those toxic material if they are polar. Some toxic material are organic based, like halogenated and fluorinated organic compound. They are not tab water soluble, so they will stay inside our cycle, inside our environment for a long time. They can't go nowhere. The plastic bags you are buying from Target or Walmart, those are halogenated, fluorinated organic compound plastic. And I mean, they are not biodegradable. They stay with you. They end up in the ocean killing a lot of fish because the fish suffocate. They trap inside this plastic. Not enough ocean tab water, not enough oxygen, dissolved oxygen come to their lungs, they'll die. So, and that's the problem with those plastic. That's an example of plastic bags. And now you'll see, as you see the initiatives taken by most of stores, they have biodegradable bags. They tell you this is nature friendly, means biodegradable means after a while, the whole bag will be just broken in small pieces, no harm to the environment. Not the plastic ones, the old plastic ones, those are not biodegradable, means they stay as they are not tab water soluble. The ocean cannot dissolve them, they stay there. And because they are not soluble in tab water, they are soluble only in fats or oils. So they will stay millions of years there and cause a lot of damage to the environment, to marine life, especially marine life are affected with those plastic bags, which is nowadays replaced by biodegradable bags. The exposure of those toxin here or toxic material, those chemicals or those bad chemicals, they can enter in our bodies, in our food. That's when you warm your food using the box, the plastic bag, the source of entering those in our bodies. They can come from the air.
What are those called?
What's that?
The chemicals that are caused toxins to our food from the boxes. What are they called?
Toxin, this halogenated and fluorinated organic compound. Halogenated compound means chlorinated and fluorinated organic compounds. Which the problem is, those are tab water not soluble. So if they are soluble inside the ocean, the salinity of the oceans will be enough to break them in small pieces. But they are not the case. They are not even affected by salinity of the oceans. They stay there.
Okay.
They stay there.
Is microwaving your food, is that dangerous? Because
microwaving your inside somebody has the lunch box? No one? You know, when you take the box inside, the plastic box, the white one?
Yeah.
That has halogenated compounds.
Okay.
Do not try to warm it up.
Okay.
Take it out, take your food out, put it in a ceramic plate.
Okay, but if you're just using a microwave and you're using something else, a microwave...
No, it will not affect you. As long as you warm it up, you heat, you evaporate those compounds out of the box material.
But microwaving is okay?
Yeah, microwave is okay.
Okay.
Because the microwave, the radiation of microwave, after that comes radio wave, correct? And then before that, the infrared wave. So those are all those waves, and then the visible. So it comes visible, IR, and then microwave, and then radio wave. Those are energetic less hazard for our bodies. Now, if you go the other direction of the spectra, you have UV coming from the sun. That's very bad. You have X-ray. That's worse. And the most worst ever is gamma rays. So if you go this way here, you get UV, correct? Then you get X-ray, then gamma. The other side, visible, that's what we see. And then you get IR, infrared. Then you get microwave, then you get radio wave. Radio wave is very harmless. Very harmless. It's causing nothing for our health.
Where do you get gamma rays from?
What's that?
What does gamma rays come from?
Gamma rays coming from interaction of the atoms or collision of those electrons inside the nucleus, and they will come up, they will be emitted.
Okay.
Large molecule, in large atoms, they will come just emitted there.
Okay.
And the X-ray is coming from the planet, from the stars as well, and the sun, like UV. Another source for them, the major source for them is the sun. UV is from the sun, and the X-ray from the sun, and gamma to some extent from the sun. Okay, guys?
Yes, thank you.
Yeah. The two definitions here, biomagnification and bioaccumulation. As you see, the word is magnification, make it bigger and bigger and bigger from biology point of view, and accumulation is accumulating, adding itself to the biology. So that's what he said. Bioaccumulation, always two words combined together. Biology plus accumulation. Biology plus magnification. So bioaccumulation, this refers to the fact that organisms may selectively absorb and store toxin in their bodies. And they are not affected if that's a small dosage. If they are absorbing large amount of it, they will be affected, and that will be a lethal dose or lethal dosage, and they will be killed by those large amount. But they accumulate small amount of toxin inside. Now, like some fish, and then we come on and then feed ourselves on that fish. So we have now in our body those toxins, those toxic chemicals. But as I said, in a small amount. Now, when you age, those small amount enough to generate tumors to cancer. Are you following me here? Mm-hmm. They started small amount, accumulated from the fish. Exactly, I mean, mostly it's from the fish here. And then you eat the fish, and then you end up having those small, tiny amount. Your immune system is weak because you are getting old. And therefore, you will see a lot of diseases will appear because of the presence of small amount of those toxin or those chemicals. You don't know the source of it, but it's come from another source you have eaten. Biomagnification says when the burden occurs when the toxic burden of a large number of organisms at a lower trophic level is accumulated and concentrated by predators at higher trophic level. Well, the trophic level is the food chain. Like, when I say trophic level, means just like a pyramid. We started with the producer, the trees, and it goes all the way to the top, the pyramid itself. So trophic levels is relating itself to the food chain producers. Food chain producers. So that's the level here. So it started starts magnifying itself. The tree is eating its food from the soil. The soil is getting some rain, which has those chemicals, acid rain, whatever, vented to the air will come back to the soil. The animals is feeding itself from this trees, producers. We are eating from this producer. So those are accumulating and magnifying itself because you are eating from the same food every day. So you are accumulating this toxic chemicals through the years. So those chemicals coming from the rain, from the skies, or come from the soil itself by you have soluble toxic chemicals seeps into the soil itself. Persistence makes some organic pollutants especially harmful. Well, that's really true, and we have a lot of pollutants around us here. I mean, because of the industry here, especially mining industry. Mining industry has the risk to have a lot of pollution there, such as heavy metals. We have lead, we have mercury, and some organic compound, the PVC pipes, plastics. Remember I told you the plastic? Now the same thing with the food box. That's another type of plastic, but it does have chlorinated. The C stand, PVC stand for polyvinyl chloride. It's halogen. There is a halogen there. Chlorinated and fluorinated organic compound. They do have a lot of side effect. I mean, a lot of toxic features on our bodies. See, that's And some pesticides some pesticides they do have this effect as well. So some pesticides they use chlorinated and fluorinated organic compound. Chemical interaction can increase toxicity. That's always true. You have toxic material will come in the neighborhood of another toxic material. They will interact, they will react, and then producing a third chemical, which is worse than to start, worse in the effect from the starting two toxic material. You started two toxic materials, they come into interact or react, and then you produce a third one, new one, which is much more harmful to the environment or ourselves than you started with two simple ones. And so antagonistic means they interfere with each other, resulting in very highly toxic features, and then compared with the starting material they started from. Our materials are additives when they are occurred together in exposure, and that's always true, because as I said, you have two chemicals and both of them are toxic. Bring them together, they add themselves to each other, they interact, and we produce a third new toxic material, which is worse than the way we started with. That's always the case. Always, most of the time, that's always the case. Synergism is an interaction which one substance has a bad effect on the other. Correct? One interaction of one compound on a bad effect on the other ones. Well, that's happens as you have two toxic materials. You bring them together. Most probably, you bring a new one out of their interaction, which is worse than you started with the two materials. Correct? The characteristic, they add their bad, dangerous chemical properties to each other, and you get up with one is much worse than the other. Toxicity and risk assessment. Well, the dosage always makes the poison. That's really true. Small dosage or small dose, it's not affecting. Your body can deal with it. Your white cell can fight it. But then if the dosage is too high, then the body cannot fight it, and our bodies and animal bodies and all the stuff, they will fail to fight those toxic poison or toxic chemicals. And as I said, they'll tell you how the materials delivered, what rate. All those factors are determining the toxicity. Not only the main thing is the dosage. That's number one. The second one, how they are introduced and at what rate. So if you are exposed like small tiny amount every year, it's not like you have the same amount every day. Are you following me here? Or not the same amount every hour. So the rate by which our body absorbing those toxic chemicals is very important. So, and that will affect the mechanism of living creatures. So we usually test toxic effects on lab animals, and well, that's really true. Most of the time they use mice, rats for this. They see the exposure of those animals to those chemicals, and then they have LD50, by which that's we can test the lethal dosage of any hazardous chemicals. So, and it says here very obvious. It takes hundreds, sometimes it says here, hundreds of those, poor animals here to be tested on. So it's not a test just one animal, and you are satisfied with one test. You have to have a precision. Precision means you repeat and repeat and repeat, and you get the same effect. Then you can get yourself a conclusion out of this redundant tests or repeated tests. So you have to repeat and repeat and repeat, and sometimes a couple thousands of those pure animals. I say poor because they have nothing to say, but they are exposed to those chemicals, and you can see them in pain. They are really crying, like a human is crying. So they are crying in pain, and the effect of this toxin or this toxic chemicals is observed. And if you can see here, that's a mouse, and the LD5, this lethal dosage or lethal dose, is 50. That's what they decide. That's what decide this is. This is the amount of the. That's how is this sensitivity of these chemicals towards this poor animal here. So if the dosage is 50, say, so 50 milligram in 1,000 milliliter of a solvent, if this is the death of this animal is perceived as dead, and the effect of this lethal dosage is recorded. So you can see here, the higher you can go here with this dosage, see here, you can read from this graph this dosage here, this dosage or dose, and here the percentage of population by given dose here. How many is dead? Start crying, and then they flip and they die. So you see small amount of doses start here. That's small amount, and you go higher, then you get 100% of your mice or rats population is dead, because you have increased the dosage up to 100%. And they describe this viscosity is to determine the dosage to which 50% of the test population is sensitive or dead. So 50% of this mice population dying, that will be the lethal dosage. You don't exceed it, correct? So that's the way they can determine the lethal dosage using the animals, especially mice and rats, though they are used. There is a wide range of toxicity. Yes, there's always wide range of toxicity. There's some toxic chemicals. Few drops can kill a big elephant. Okay, and some toxic chemicals you need a lot of amount to kill a big animal such as an elephant. So they have a range. I mean, that's always the case. And just to tell you the cyanide, you heard about cyanide, potassium cyanide, sodium cyanide. The cyanide, a small tiny amount, couple milliliters, will kill a human in few minutes. But if you add too much of it over the LD dosage, over the lethal dosage, that can get your big elephant in few minutes dead. Depending on the amount of this lethal dosage, on the amount of the toxic chemicals, you will see this amount is very, very sensitive, very, very important, very sensitive to the bodies itself. The more you take in, the faster you'll die. The less you take in, the slower you die. So that's what. So super toxic chemicals are extremely potent for some few organisms. Just millionth of the gram is enough for a lethal dose. That's what I told you. couple drops, not drops, couple, say 1 or 2 milliliters enough to kill of the cyanide to kill a human. Now, for those milliliter will be not enough to pull this elephant down. You need more dosage than just 1 milliliter or 2, correct? So maybe, I don't know, maybe I did not looked it up, but maybe 10, 20, 50 mils of potassium cyanide enough to pull this in a couple of minutes to pull big elephant dead. So it depends on the type of the chemicals and the type of the animals you are dealing with. Toxin can have acute or chronic dosage and effects. Well, that's two definitions. What's the difference between acute and chronic? From the word acute happened what? Now. Single dosage happened now, correct? And it has immediate now. It has immediate effect. You can see it. The chronicle, as you see from the word itself, it's a prolonged, it's a single disorder, but the effect is it takes time to see a result of this effect of this toxic material on that object, correct? Whether it's human being or animal or marine life or even trees, the producer. So it's chronic and acute effect. Well, the acute effect is always you are dealing with a very, very highly toxic chemicals. Very highly toxic chemicals. You can see the effect of it, such as the cyanide. Cyanide, you see the effect of it in 1 minute or two. Person dead, correct? And same thing, animal like elephant, a couple of minutes dead. But in the chronic effect, you cannot see it at once. Immediate observation cannot be seen. It takes a very long time to see the effect of it, correct? See the effect of it. And this here too. Unlike acute effects, you can see it, immediate results of it. The specificity for chronic exposure is difficult. It takes longer time, and it has other factors affecting. As I said, if somebody is too old, you will see the effect coming faster. If you see a young person, then you'll see the effect will not affect like an old person. There are other factors affecting the acute and the chronic behavior or effect of those toxic material on our environment and ourselves. Degree of toxicity varies widely. That's always true. Okay, that's always true because not all the toxic material will behave similarly. No, there's some toxic material will affect just the inhale exhale operation in the body. Some of them will just the filter of the body, which is the kidneys. The fluid filter of the body is the kidneys. So those chemicals, depending on what you have, like for example, I told you this the pollutants inside mining is mostly become lead, heavy metals, lead, mercury, iron, rust. All those metals will not affect anything in the body. They will affect two things, kidneys and livers for some reasons. When they accumulate there in the kidneys and the livers, you see their effect immediately. That the person has heavy metals, heavy pollutants of lead, mercury, iron, all those metals here, and especially in the mining area. And here's an example: low dosage of DHEP suppress the activity of enzyme essentials for the rat brain development. So they give a toxic material here, DHEP. That's a toxin, and they put that's a toxic chemicals, and it has only effect on the brain, not the liver, not the kidney. So those toxic chemicals, they are really affecting some specific parts of the organ inside the body of the animals, humans, marine lives, and so on. So this here, another toxic material, will affect the brain. will affect the brain. The rat is going from left to right straight, does not really recognize anything. You can see the rat or the mouse has no control in its motion. So the brain is really affected. So it's like you are paralyzing the brain with this low dosage. Now, if you increase, that will get a lethal dosage of this toxic DHEP compound. Risk assessment. Well, it's sometimes very difficult to assess a risk with associated with those toxins, with those toxic materials. It's very toxic chemicals. It's very, very difficult because you have to accumulate a lot of knowledge of this toxic material first, and then see what's the probability of the exposure of those toxin or toxic chemicals released in the environment on us, on the living creatures. So as here said, it's mentioning, is very difficult. There are many factors complicate the movement and the fate of chemicals both around us and within our bodies. It's always the case. Public perception of environmental hazards can be inconsistent with actual risk. That's always the case. You have to have a full knowledge about the chemical or the toxic chemicals you are dealing with. And you have to do a lot of lab experimentation to know that. Using animals or using no animals, both. You need the animals to see the effect, and you see to take these chemicals and then try to accommodate this chemical to make it less harm on the environment. So the risk assessment is the most difficult part because a lot of factors are missing. A lot of factors are missing in the assessing the risk of those chemicals exposed or vented to the environment. Our perception of risk is not always rational. That's always true. That's always true, as I say, because we are lacking a lot of information about those toxic chemicals. A lot of information is missing. And even the manufacturer manufacturing those toxic material needs to go back and revisit those side effects and all the effect, the negative impact on those chemicals. So it's not really a solid area. You know that this is 1 + 1 = 2. It's a lot of factors affecting those toxic chemicals vented to the environment. As here says, we have an exaggerated view of our own abilities to control our fate. And that's really true when it comes to toxic chemicals vented to the environment. How much risk is acceptable? Well, it's difficult to say how much risk is acceptable. So if you say that's lower risk is acceptable, that's the way we can go with. But if you have those chemicals are vented in large amount, then the risk is very high and it's not acceptable. Then the intervention of the authorities come in play. So it depends on the amount of those toxic material released to the environment. How much of those toxin, how much of this chemical toxic material is released to the environment, and what side effect and they have. So most people will tolerate a higher probability of occurrence of an event if the harm caused by that event is low. So we vented a chemical we know that's toxic, but in a small, tiny amount, so our body is not detecting this harmful behavior of this toxic chemicals. Now, if the dosage or this amount of these toxic chemicals is vented to the environment is large, then we have to put the authorities in play and come and and come and help in cleaning up those chemicals away from our rivers, from tap or reservoir, from the soil, and from the air. EPA generally assumes that a risk of 1 to 1 million is acceptable for most environmental hazards. For activities that we enjoy, we are often willing to accept far greater risk than this general threshold. Well, 1 to 1 million, that's a small, tiny amount. So if you look at the concentration of these toxic chemicals, 1 to 1 million, it's very, 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 very tiny. It will not have that much of effect. Takeaway points. Well, we have seen that a lot of harmful chemicals are really cleaned up, but not every in every country. You know, some countries still they are having problem with this toxic chemicals being seeped into the rivers and ponds and even oceans. We have chronic conditions that once were confined to rich countries. Now they are become leading health problems nearly everywhere. And that's really true. That's really true. You have a lot of chemicals are dumped, even in a very developed, such as India. India, some rivers you cannot even swim, you cannot drink normal tap water because some industry regulations is not that strict enough, and they dump some of their chemicals inside those rivers and ponds, and you cannot use those type of rivers or ponds. Emergent diseases that they were there, not there 20, now. For 20 years they were disappearing, but now they are coming back. They are coming back, and that's what emergent diseases. They were absent for 20 years or more. They are becoming back at increasing rate. Okay, so and then you have international travel. Disease can be spread around the globe in a few days. COVID is an example of how the disease is spread all over the globe. Modern industry is introducing thousands of new chemicals every year, most of which aren't studied thoroughly for longer-term health effects. And that's what I told you. We are lacking a lot of information about those chemicals, and the manufacturers, they have to go back sometimes to revisit those chemicals and their effect on the environment and on the biology of living creatures. So it's very hard to know. I mean, everything they produce, the amount is produced of those chemicals when vented to the soil or to the air or to the ocean or the tap, or then they will have a very negative impact. So that's chapter 8 about chemicals. And as I said, look for what? Look for the definitions in each slide, and put them aside with the small tiny notes for yourself, so you know what the definitions are. Correct? The final exam, I don't know. I'll let you know, because the final exam for the whole what they call it, the whole department, they will have the same standardized exam. So I will be using it, but I will have a look into it. So I'll peek into it and see what's the trend. But those quizzes here, I saw the publisher quiz I'm using. Those are definitions per se. I'm not going to chapter 7. I will go chapter 7. I'll let you go earlier here, 5 minutes earlier, a bonus. Or you want to see chapter 7? Okay, no chapter 7. Okay, now, no. Okay, so don't forget that quiz number 2 will be due tonight. Quiz number 2 will be due tonight. Here it is. Will be due tonight. Okay, guys. Thank you very much.